Hi, so this is the Math 83 section on solving equations by factoring. So in the last few videos, we learned how to factor, and I really recommend you watch all of the factoring videos before you watch this one, because this one is based on being able to factor. So all we know how to solve in this class so far are linear equations. So we know how to solve things like x plus 5 equals 3. Okay, we know that we just subtract 5 from both sides of the equation and we end up with x equals -2. We know how to solve things like 2x minus 1 equals 7. Well, we have to do a little bit more work here, but we add 1 to both sides of the equation and then we divide both sides by 2. Okay, so we know how to solve this type of equation. What we don't know how to solve yet are equations that maybe aren't linear. They don't have an x squared. They don't have an x in them. They might have an x squared. And we'll see one in this section that even has an x cubed, that if we know what to do, we're able to solve it. So our point here is to take an equation we don't know how to solve and make it into an equation or two that we do know how to solve. And we're going to do that by factoring. So let's do a quick example. Let's factor the trinomial x squared minus 4x minus 12. Okay, we know how to factor this because of the factoring videos before. We know that this is going to have an x in both sets of parentheses because the leading coefficient is 1. All right, now we need to find two factors of -12 that add to -4. So we know that they're going to have different signs because their product is negative. And we know that the bigger number is going to have to be negative because the sum is negative. So we can run through them all just for fun. These don't make -4. These do. Okay, so these are going to be our numbers. X minus 6, x plus 2. Okay, so we factored it. Now, what we have just done, though, is turn something that has an x squared in it into two pieces that each have an x. And we can solve an equation involving this expression. And we can solve an equation involving this expression. So that's going to be our whole point in solving by factoring. If we have an equation in this or with this expression, we want to turn it into something like this because we know how to handle these in an equation. So what we're going to use is something called the zero product property that everybody already knows. You just probably don't know it called the zero product property. So the zero product property says, if we have two expressions and their product is 0, so two things multiplied together and the product of that multiplication is 0, what we know is that A equals 0 or B equals 0. One of these has to be 0 in order to get 0 as a product. That's the only way that can happen. So this is what we're going to be relying on whenever we solve by factoring. We're going to turn something that has an x squared in it into, or an x cubed even, into a product of things that we know how to handle. And if that product is 0, we know what we're allowed to do with each of those pieces. We set them equal to 0 and solve the equation. Okay. The thing is, though, this has to happen. One side has to be 0 before you're allowed to do this. Sometimes that's the case, sometimes it's not. So if it's not the case, we have to make this true before we're able to factor and then solve these little equations. All right, so let's do some examples. All right, so we're going to solve x squared minus 3x plus 2 equals 0. Okay, so again, this is an equation that involves an x squared that we have never dealt with before. But what we're going to try to do is turn this side into two pieces that we do know how to deal with. Now remember, one side has to be 0 before we're able to use the zero product property, and it is. So now we're just going to leave this side alone and we're going to factor the left side so that then we can use the zero product property. All right, so we're going to factor this just like normal. Just don't forget to put the equal 0 on the other side. It's got to stay there. But this has a leading coefficient of 1, so we know the factors are going to have an x and an x in them. We need two factors of 2 that add to negative 3. Well, because the product is positive here, we know that these two factors have to have the same sign. And because the sum is negative, they're both going to be negative. So we look at factors of negative 2. There aren't very many. In fact, we look at the factors of positive 2 that are both negative. There is exactly one pair of them. So our numbers here are going to be negative 2 and negative 1. Okay, great. So all we've done in this step is factor this left side, and we're here. But now we have the situation where we have an expression times an expression that equals 0. So we can use the zero product property. What this means is that either x minus 2 equals 0 or x minus 1 equals 0. And now our job is just to solve these two little linear equations. And we know how to solve those. We did an example of that just a second ago. In this one, we're going to add 2 on both sides. So we get a solution of x equals 2. And here we would add 1 on both sides, and we get a solution of x equals 1. So we actually have two values for x here that would satisfy that equation. If we replaced x with 2, we should get a true statement. If we replace x with 1, we should get a true statement. But this is the general process. Make sure your expression is set equal to 0. Factor the expression, the quadratic expression here. By the way, this is called a quadratic expression. We haven't called it that yet. But factor the expression here. And then if you've got something factored equal to 0, you can set each one of those little pieces equal to 0. Let's do another one. All right, now the instructions in your notes just say solve. It might say solve. No, they say solve by factoring. My instructions just say solve. We're going to talk about different ways to solve these in future lessons, but for now we're solving by factoring. So let's look at y squared minus 25 equals 0. All right, well, we just learned in the last factoring video how to factor something that looks like this. And also we've already got it set equal to 0, so we're all set to do what we need to do. So what we decided in the last video is if we've got a difference of squares, we know how it factors. So y squared is obviously y squared, and 25 is 5 squared. Okay, so now we have this format here, so we know how to factor it. Their sum times their difference. Okay? And since this factorization is equal to 0, what we know is that either y plus 5 equals 0 or y minus 5 equals to 0. Which means we subtract 5 on both sides and y is negative 5. Or we add 5 on both sides and y is positive 5. So once again, we have two values for y, two solutions to this equation. And in general, that's what's going to happen when you see a squared here. You won't have any more than 2. Let's just say that. Okay, now let's look at what happens maybe if one side isn't 0, and then we'll save the rest for the next video. Okay, so let's look at 5x squared minus 3 equals 14x. Okay, so what we said from the beginning is that if you want to solve these things by factoring, one side has to be 0, and that is not the case here. So we cannot factor until this side is 0. So our first step here is going to be to make this side 0 by subtracting 14x on both sides. Now you could put this 14x in, or this minus 14x anywhere you want on the left side, but we're used to seeing these things when we factor in descending order. So I'm going to put it in the middle. Okay, so we know how to factor this side, and now since it's set equal to 0, we can factor and solve by factoring. So you can factor this any way you want. Since my leading coefficient here is 5, I know that I'm not supposed to be putting an x in each set of parentheses. That's not necessarily going to be the case. But you can do AC method here if you like. Trial and error wouldn't be too bad though. Let's go with trial and error. Some people really like it. So for our first to be a 5x squared, we have 5x and x for our firsts. And for our last, the product of our last to be -3, they have to be 1 and 3. Those are the only factors of 3, and we're just going to have to play around with the negatives to get a -14 here. So let's try a 1 here and a 3 here. So if we do outers, that'll be 15, inners, that'll be 1. And I know that -15 plus 1 will give me -14. And that's how it factors. Now, this one happened to be pretty quick, but if you wanted to use AC, you can, and we'll actually use AC in the next video, in our first example. But in any case, now that it's factored and set equal to 0, we know how to get the solutions. We can set each factor equal to 0. And we solve each equation. We know how to solve something like that. Subtract 1 on both sides. And then we can divide both sides by 5, and I don't have any room to write it in my frame, but you would get x equals -1/5 if you divided both sides by 5. And this one's a little bit shorter. We just need to add 3 on both sides. So our other solution is x equals 3. Okay, so we'll do a lot more examples in the next video, and we'll do the AC method just for some extra practice.